Good morning, this is your Stat Sensei, Mr. Sensei, and this is Lightbulb scenario on the normal distribution. We're going to be working with actual data, not just z-scores. A particular brand of light bulb is normally distributed with a mean of 1500, so our mean is 1500, and our standard deviation is 75. What's the probability the light bulb will last less than 1410 hours? Okay, so we're always going to go ahead and define our variable. They told us this was normal, so we need to say it's a normal distribution. So there it is, normal. And we need to define our variable x. So let x equal how long a light bulb lasts. All right, so our first one, we're going to draw our picture. We're centered at 1500. 1410. And so z equals x minus mu over sigma. We want the probability that z is less than 1410 minus 1500 over 75. So I'm going to do a stat test z test. Stat test z test. Mean 1500. Standard deviation 75. X bar 1410. N is 1. We want less than. Calculate. Probability z is less than negative 1.2. Equals 0.1150. All right, what's the probability the light bulb will last more than 1,583 hours? So once again, we draw our picture. This is 1500. We want 1,583. We're shading up. So the probability that z is greater than 1,583, that's our x, minus our mean of 1500 over our standard deviation of 75. Stat test z test. Stat test z test. Mean is 1500, standard deviation is that 1,583. Make sure we change our direction of our inequality. And we get the probability z is greater than 1.106. Probability that z is greater than 1.1066 equals 0.1342. What's the probability that the light bulb will last between 1563 and 1648? All right, so I'm going to do it the long way first because this is the way you need to do it if you're taking an FRQ test because you have to show everything. So my mean is 1500. This is 1563. This is 1648. We're shading here. So we always start with a high one. So the probability that z is less than 1648 minus 1500 over standard deviation of 75 minus the probability that z is less than 1563 minus 1500 over 75. Z test. And we're starting off at 1648. Change that to a less than. And the probability z is less than negative 1.973. Gives us a probability of 0.09757 minus probability that z is less than something. So stat test z test. Changing it to 1563. Oops. Probability Z is less than 0.4. And we end up with 0.7995. So 0.9757 minus 0.7975. Oops, 7995 is 0.1762, which is our answer. Again, the short way. If there's multiple choice, second vars, norm CDF, lower bound 1563, upper bound 1648, mean of 1500, standard deviation of 75. And we get to 0.1762 again. All right, what's the probability lasts between 1416 and 1677? 1416, 1677. So the probability that Z is less than 1677 minus our mean of 1500 over our standard deviation of 75. That's the upper one, minus the lower one, the probability that Z is less than 1416 minus 1500. Notice it's 1400 is below, over 75 is below the mean. So there we go. So we're going to have the probability that Z is less than, let's do the upper one, stat test, Z test, 1500, changing that to 1677. And we end up 0.9908 and a Z score of 2.36. Probability that Z is less than 2.36 is 0.9908 minus probability that Z is less than, and we'll change that stat test, Z test, 1416. That's my lower bound right here. And negative 1.12, probability Z is less than negative 1.12. And we came up with that being 0.1313. And we subtract those two, 0.9908 minus 0.1313 is 0.8595. And of course, I could have done a norm CDF. I'm going to write everything out this time. Norms CDF, lower bound 1416, upper bound 1677, mean 1500, standard deviation is 75, lower, upper, mean, standard deviation. Let's run it real quick. Second vars, norm CDF, 1416, upper bound 1677, mean is 1500, standard deviation 75, and we get 0.8595. All right, I appreciate you watching, and I sure hope to see you on the next one. Thank you.